ladies and gentlemen. My name is Adebanjo Olaniko Peter, BSc Maths, OAU, MSc Maths in View, MBBS, University of Technology, Promotion. I'm here this afternoon to dish out a little aspect in physics we refer to as the scalar product of vectors. We should know that scalar product is otherwise known as dot product. Call it dot product. I'll say scalar product, or you simply call it dot product. Suppose we have two vectors, A and vector B. Now, the dot product of the two vectors A and B is written as A dot B, and there's a dot product. A dot B is expressed as magnitude of A, magnitude of B, cos theta. And from here, theta is the angle that is between the two vectors. So we can write this one as cos theta equals to A dot B divided by magnitude of A, magnitude of B. So it is very possible for you to get the angles that is between two vectors. What does that mean? If I want to get the angle between two vectors, it simply means I will say theta is equal to cos inverse of A dot B divided by magnitude of A, magnitude of B. That's how we can get the angles that is between two vectors. Now, two vectors can be parallel together and it can be perpendicular to each other. If two vectors are parallel to each other, we have parallel vectors, we can say theta equals to 0 degree. That's for parallel vectors. But if theta is 0 degree, what does that mean? It means this implies that we have A dot B equals to magnitude of A, magnitude of B, cos theta. But once we have theta is 0 degree, this will give us A dot B equals magnitude of A, magnitude of B, cos 0 degree. Since cos 0 degree is equal to 1, we now have what? Our A dot B to be magnitude of A, magnitude of B. So when you have dot product like this, dot product to be the product of the magnitude of the two vectors, we say those two vectors are parallel. However, if two vectors are perpendicular, if theta equals to 90 degree, you have it as perpendicular vectors. This perpendicular vector. This one is a symbol for perpendicularity. So if theta is 90, it implies that we have A dot B equals magnitude of A, magnitude of B, cos theta. But since our theta is 90 degree, then we have that A dot B equals magnitude of A, magnitude of B, cos 90 degree. And since we know that cos 90 is 0, then A dot B is equal to 0. This one, condition for two vectors to be perpendicular to each other. That's the condition for two vectors to be perpendicular to each other. Let's take for instance let's say that you are given a vector A. Let's say it is two component vector 2i plus 3j. And we are given another vector B. Let's say it is 5i minus j. And we want to find one. Let's say we want to find A dot B. We want to find B dot A. We want to find magnitude of A. I want to find magnitude of B. So for the first one, like we want to solve A dot B, we write our A out 2i plus 3j, dot it with our B 5i minus j. So we are going to use the coefficient of I to multiply the coefficient of I here. That is 2 multiplying 5 plus, we use coefficient of j to multiply the coefficient of j here. That's 3 multiplying minus 1. So this will give 10 minus 3. Answer is 7. Meaning that scalar product must give you a scalar. What does that mean? When you dot two vectors together, you will get a single number. That is a scalar. So if you find A dot B, you get 7. If you find B dot A, it's most likely you get the same result. Meaning that if you find B dot A We find B dot A as the second one, and we find B dot A. It means that we have our B to be 5I minus J, and we have our A to be 2I plus 3J. So in that case, the 5, we multiply the 2, plus the quotient of J here is minus 1, we multiply the 3. So here we have 10 minus 3, that's 7. You can see that our A dot B is the same thing as our B dot A. This implies commutativity of scalar product. It means that scalar product is commutative. Commutative means you multiply A and B, you dot A and B rather, you get an answer, you dot B and A, you get an answer, and both answers are the same thing. It simply means scalar product is commutative. That's commutativity of scalar product. However, we can get the magnitude of A and the magnitude of B. You are giving A, our vector A, to be 2I plus 3J. So if you are getting magnitude of A is square root of, the quotient of I here is 2, you square it. The quotient of J here is 3, you square it. And in that case, you have your magnitude of A to be square root of 4 plus 9. So in this case, you get square root of 13. That's square root of 13. And the last one, we want to get the same as the magnitude of B. Since you have vector B as 5I minus J, I want to get the magnitude of B. The magnitude of B is going to be square root of the quotient of I, 5, we square it, plus the quotient of J. Mind the quotient of J is not 1 here but minus 1, that's minus 1 squared. So magnitude of B is going to be square root of 25 plus 1. So the magnitude of B is equal to square root of 26.